Hello everyone, today I'm going to show you a quick video guide on how to solve self-study exercises number 13. The first problem will be in this video and problem number 2 will be done in a separate video. Okay, the first question, there's a contact process for the manufacturing of sulfuric acids. It contains one important stage, which is the conversion of sulfur dioxide and oxygen into sulfur trioxide. Okay, so the first question in problem 1 is to write equation, a chemical equation for this conversion. I've already done this part. So we have sulfur dioxide gas reacting with oxygen gas in a gaseous form again. Because this reaction is reversible, I put an equilibrium sign and we are forming sulfur trioxide, right? We have to balance for oxygens, therefore I put two coefficients 2 before SO2 and before SO3. Right, the next question is decide whether the system is at equilibrium or not. And in order to do that, you have to write the expression for reaction quotient, which is QC. And reaction quotient is what? Is a ratio between the product's concentration raised to the stoichiometric coefficients, which is 2 in this particular case, over concentration of the reactants, again raised to their coefficients, times another coefficient of the reactants, which is oxygen, right? And we know that those values were given, okay? The equilibrium concentrations, not the equilibrium, but just general concentrations are given. We can calculate them actually from the number of moles, which is given, and the volume of the container, right? So what do I have to do effectively is to divide this number of moles of each reactant and product over the total volume of the container, right? And if I do so, I can place those numbers into the expression of reaction quotient, and I'll get again the ratio of 0.015 squared, okay, over 0.0015 again squared, that's the concentration of the SO2, sulfur dioxide, times 0.3075. That's the concentration of oxygen, okay? And if we do the calculation, we'll come up with a value which is 1.33 times 10 to the power of 10, okay? And important is the unit of the reaction quotient. All of them are molar concentrations, right? So molar concentration squared will cancel with the molar concentration squared at the bottom, and then we end up with molar concentration raised to the power of -1, okay? Clearly, this number is significantly bigger than the value of Kc, right? We can say that it's greater than Kc, and okay, and move on to the next question. So, because QC is not equal to the equilibrium constant, it means that at that particular time, with these particular concentrations, the system is not yet at equilibrium, right? The equilibrium it hasn't been attained yet, and then in which direction must the reaction proceed to reach the equilibrium? Explain your answer. Well, we know that QC is so much bigger than Kc, and what it tells actually, in fact, it means that the amount of products, okay, at that particular time when you measured those concentrations is so much higher than it's supposed to be at equilibrium, so that the system will lie, or the system or the reaction will go to the left, okay? Why? Because it wants to get rid of this extra concentration of the product to reach an equilibrium, all right? So that would be the answer for problem 1-3, okay? Now, coming to the problem B, 1b. We're given with reaction between bromine gas and chlorine gas, and there's also equilibrium constant value at certain temperature. The initial concentration of the two reactants is 0.2 molar, right? The first thing, again, give us the chemical equation for the reaction. Well, we know that bromine, it's a gas, it reacts with chlorine, again gas, at equilibrium with 2 okay, forming bromochloride. Okay, it's a gaseous substance and I need to balance, right, the equation. Now the next step, write the expression for the equilibrium constant Kc. The equilibrium constant Kc would be then a ratio of the product, which is in this case is bromochloride, to the power of 2 because of this coefficient, right, over concentration of bromide or times concentration of chlorine gas. Okay, that would be the equilibrium concentration. Right, and then the final stage, calculate the equilibrium concentrations of reactants and the product. Now, we are given, let's go back to the problem again and see what is given. We are given with Kc, we know its value. We are given with the initial concentrations of two reactants. Okay, and we can assume that the concentration of the product is 0, right? Now, in order to find the equilibrium concentration, I need to set up a table, okay? So I would repeat the equation just for the sake of the visual solution. Okay, it looks clear. It's much more clear when I write the equation itself. So I know that I can write the initial concentration first. For bromine and chlorine, we said it's 0.2 molar, okay? And it's 0 for bromochloride because it hasn't been yet formed, probably. And then the change in concentration, again, in molar units. Now, it would be minus x for bromine, it would be minus x for chlorine, and it would be plus 2x for the product. And at the end we reach equilibrium. Equilibrium concentration would be then what? Would be sum of initial concentration and the change. Initial and the concentration and the change. Okay, for all of three. Now what I do next, as usual, I write the equilibrium. I already have an equilibrium constant expression, so I can plug the equilibrium concentration expressions into this ratio. Okay, so what would be the equilibrium concentration of bromochloride is 2x squared over concentration of bromine and chlorine would be then 0.2 minus x, and because this is both of them and they're equal, I can just square all of that, and that is equal to 7.2, right? Right, so now my next step is just to solve this quadratic equation, or I can simplify this expression by take square root on both sides, okay? And I end up with an expression 2x over 0.2 minus x equals to 2.68. All right, and now if I solve this equation, I would end up with 4.68x equals to 0.54. Then x is equal to 0.115. All right, and what I find is actually the what? The concentration. So I can put the units m. Okay, molar. Now, a final step would be what? To actually calculate the equilibrium concentration of bromine. 0.2 minus 0.115. That would give us 0.085 molar. And it's equal to the chlorine's concentration, right? And then the concentration, equilibrium concentration of bromochloride would be what? 2 times 0.115, which is 0.23 molar. Okay, so that would be the final values.